An AI can look at a piece of code and tell you whether it works about 9 times out of 10. Then you ask that same AI to write the tests for that same problem, and its tests throw out 2/3 of the programs that actually work.
That's the same model? Same problem, same everything? It knows a right answer when it sees one, and then it writes a test that fails the right answer?
It's the same model, the same problem, and the same set of weights. So picture a bouncer at a door. He's worked that door for years, and he can look at anybody and tell you instantly whether they belong at this party. Now hand him a blank sheet and ask him to write the guest list himself. He writes a few names, he stops, and everybody he left off gets turned away at the rope. That's the puzzle in this paper, out on August 2nd. How can it recognize the right answer and then fail to write the right answers down?
And that matters because AI is writing that guest list everywhere now, isn't it? The tests that check code, the answer key stapled to a quiz, and the grader scoring another AI. If my answer is missing from the key, nobody says the key was wrong. They say, I was wrong.
Right, and 3 things are coming. First, there's a test the model wrote that runs perfectly and still rejects the problem's own official correct answer. Second, there's a review pass that makes the whole thing worse every time you run it. And third, there's a change to the question, one change, that fixes almost all of it.
Okay, but my gut says this is impossible. It's one brain. If it can spot a correct answer, it has to know what the correct answers are. Writing them down is, it's just a different way of asking the same question.
That's the belief this breaks. And your first thought is probably that it forgot some. The authors closed that door. They showed the models the whole pile of candidates up front, 15 words sitting right there on the page, plus the rule for which ones counted, like the words with a double letter in them, with nothing to remember. It just had to copy the right ones out. Judging one word at a time was near perfect, and writing out the set was still badly short.
Huh.
Because judging and listing are not the same act. Judging is one decision, this one, yes or no. Listing is a search, where the model also has to decide, all by itself, when it's finished. And nothing in how these models are trained ever taught them what finished feels like. So it stops early, and whatever it never wrote down never comes up again.
So with code, it's leaving tests out.
Well, on code it's stranger than that. It makes promises the instructions never made. One problem asks for a function that splits up nested brackets. The instructions say nothing whatsoever about broken input. The model wrote 3 sensible checks, and then added one more, demanding the function crash when the brackets don't match. The official correct answer doesn't crash, so the test file runs cleanly, no errors at all, and it rejects the problem's own reference answer. Most of the test files they audited did something like that.
Okay, but somebody reviews these, don't they? That's what a second pass is for.
That's the part with teeth. Hand a reviewer the list and ask, is anything on here wrong? Every wrong entry is right there, a name they can point at. Now ask, is anything missing? There's nothing to point at. To ask whether a missing answer belongs, you have to name it first, and naming it is exactly the job that just failed. In their tests, reviewers caught the wrong extra entries most of the time, and almost never caught the missing ones. So each review round deletes the visible mistakes and leaves the invisible ones, and the list gets cleaner looking and stricter every single pass. So watch the same model, the same 15 words, and the same rule asked 3 ways. Ask it to judge one word, strong. Ask it to write out the members. It gets about a quarter of the set. Ask it for the rule instead, a few lines of code that pick the words out, and it's essentially perfect, better than its own judging.
Perfect? So it knew the whole time?
It knew the whole time. So, how can it recognize the right answer and fail to write the right answers down? Because describing the boundary and producing everything inside it are 2 different jobs. Walk it once. No sense of when it's done, so it stops early or invents a requirement. So the key rejects correct work, so the only errors left are absences, and an absence is the one thing a reviewer cannot check. The way I'd put it, a model-written checker is the model's weakest ability wearing the authority of its strongest.
One place this stops, though. Everything here was the model answering in one shot, with no time to think it through. When they let it work step by step, on the simple tasks, the gap basically vanished. And they never tried it against human-written code, or with several models checking each other.
Which is the useful version of the lesson. Never ask a model to list a set it could describe instead.
So, should anyone be allowed to grade you with an AI-written answer key when nobody can check what's missing from it? I say no, not until someone runs the key against an answer we already know is right.
And I'd say yes, because that one check is cheap and it works. Break the tie in the comments, and subscribe if you want the next one of these.
And the people turned away at that rope never complained. They never knew they were on the list.